file in our group. I hope you people are able to get it, find it. Have you received the file in WhatsApp group? Any confirmation?
Yes, ma'am.
I think no, ma'am.
Sorry.
Yes,
I
ma'am.
think we received any
Yes, ma'am.
file.
Received.
Received. Fine. Thank
When
you.
it was shared
Sorry?
yesterday evening. When it was shared yesterday evening.
I just shared, ma'am. I said I have just
Okay,
shared. You need to
okay,
check
ma'am.
your WhatsApp. I hope you people have found it. You need to download it today. As the agenda is, I'm going to discuss the normality and reliability part of the data. So I'm expecting you people to use the same file when I'll explain you that how we can do all these kind of things, how we can check the reliability, how we can check the normality of the data, right? So that we need to do. Give me a second. I'm going to share my screen and then I'll start with the session. So give me a second. Okay. Thank you, Ratika ma'am, for the confirmation. Fine. So I think before talking about reliability and the normality, can anyone tell me what do you understand by these two terms? Do you have any idea? Can anyone throw some light on these two concepts?
Ma'am, normality means how the data is normally distributed. Is the data is normally distributed or is distributed in one side, either right hand side or left hand side.
Yes.
And ma'am, reliability means how data is consistent and how data is reliable. So you can use this data every time when you are using the same population.
Very good. I think it's in the real, sir.
Yes, ma'am.
Yeah. Thank you, sir. It's very correct. Sir had said very correct. Yeah. Most welcome, sir.
Reliability is also our dependability on the data, especially for the decision making. If we are using reliable data, then of course our decision making will never go wrong.
Okay.
So it depends upon the robustness of the data, how accurate it is. All these dimensions will make the data reliable.
Okay. Okay. May I know the name?
Professor Ekta.
Meghna ma'am. Yes.
No,
Mr.
Ekta. Ekta.
Sorry?
EKT. It's Ekta. Professor Ekta from Delhi.
Ekta. Sorry. I think cooler is running in my room, so I am not able to hear you properly. But I think I am audible clearly. Is it fine? You people can hear me properly?
Yes, ma'am. Yes, ma'am.
Yeah, fine. So, okay, Ekta ma'am has also said, with a few extent I can say she is also very correct, right? So now I think I'll try to put my view on these two terms, these two terminology or these two very important concepts of these statistics, right? So today I'll start with the firstly in reliability. I'll talk about the various methods and types of reliability, and then we will talk about normality and the methods of testing the normality of our data, right? Starting with the reliability. I need to shift it somewhere here, right? Now, if I talk about reliability, I'll try to discuss reliability on the four quadrants. The first one says what is, means what is the reliability. According to me, reliability is nothing but it is a measure of consistency. So I think we all are well versed with the term consistency. Consistency means when something is constant over a period of time. That is consistency. So similarly, if I talk about reliability terms, term in case of research. So here we are bothered about the reliability of the questionnaire. Questionnaire means it's a scale or it's an instrument also. So if you are using any scale, if you're using any instrument, if you're using any questionnaire for collecting the data, first you need to check whether whatever construct you are measuring using that questionnaire, that is reliable or not. So you need to test the reliability of the questionnaire or of your scale, right? So that way you would be ascertaining this thing whether your scale will be constant scale if you are using the same scale again and again, whether it will produce the same results or not. So that way it is known as the term reliability in statistics. Second parameter I'll talk about, when. So means when you need to test the reliability of your scale. So the condition is when we are using the variable which are on the Likert scale. Usually whenever we are having the variable on Likert scale, especially in that case, we are checking the reliability of the scale or the questionnaire. But in some cases, when the scale is not Likert scale, in that case also we can check the reliability of the scale of the items which we are having on that particular questionnaire. Talking about the next thing, next quadrant is talking about the where you need to test the reliability. When means what should be the type of your, what is the nature of your variable that you need to decide upon. Where means in which condition you need to test the reliability. So there are two things. First thing, if we are using the existing scale, means our scale which is developed by the previous researchers, previous authors, if you are referring their scale, in that case also you need to test the reliability of your scale. Because here the context is why I'm talking about this, because if you're using the scale of the which is already developed, which is already tested, but still if you're using in your context, the possibility is that the time period or the time gap will always be there. Second reason means in which area you are using, that can also be one thing. For which population we are using, that can be the other thing. So that way there are numerous reasons which are forcing or which are telling us due to these some reasons you always need to test a reliability of the existing scale. Further, second condition is when you are developing your own scale, means if you want to make or create your own questionnaire. Suppose you are interested to measure the satisfaction of the customers who are visiting a restaurant, right? So in that case, it is quite possible skills will be available in the literature. But if you want to develop your own skill, you are writing your own items, you are writing your own statement in a questionnaire. In that case, it is mandatory. You need to check the reliability of your skills. Generally, using the pilot study, where we are conducting this particular study for 25 to 30, 35 to 30, 35 to 40 people around, means on a small group of people, you are circulating that particular scale. That way you will collect the data and then you can test the reliability of your scale. So this way, whether you are using the existing scale or you are developing your own scale, in both the cases, generally it is suggested to check the reliability of the scale. Further, next question is how to check the reliability. So I think answer is very simple. There are various methods available. Using those methods, we can check the reliability of the scale. So in the upcoming slide, we will talk about types and the methods. So the next slide says types of reliability. So usually or broadly, I can say that we can divide the reliability into the two categories: stability and the internal consistency. Stability means which is stable over a period of time. Means stability I'm talking about in terms of time period. So over a period of time, if I'm using the same scale and it is producing the same result, so that way it is reliable scale because it is consistently giving you the same output, right? Internal consistency meaning is if you are using any scale, so there will be certain number of items on that scale, and if those items are internally consistent or internally related to each other, that way you can say this is known as the internal consistency of the scale. So these are the two types of reliability usually available in statistics. Further, you can see what are the methods which you can use to check the reliability. So these are the four well-known methods: test view test reliability, parallel form reliability, split half, and internal consistency reliability. Usually the first two we can keep or we can use to check the stability stability component of the reliability or of the scale. So whether your scale is reliable over a period of time or not, in that case you can use test reliability and the parallel form reliability. So all four I'm going to discuss one by one in upcoming slides. I think till now it is fine. May I go ahead?
Yes, ma'am.
Yeah. Thank you. Talking about the first scale, which is test reliability. So here, I think you can see there is so much theory I have written on the slide. But rather than talking about the theory part of like this, for the test reliability, I I have developed a diagram. You can see, using this diagram, I think you would be able to understand test retest reliability probably in a better manner. So here you can see, initially you can find, I'm talking about a test. Test is what? It is a scale, or it's a questionnaire, or it's an instrument, right? So if you're having any test or questionnaire, you need to administer that particular test within a 6 months time gap, right? Here you can see, firstly, I'll conduct the test on a group of respondents. And for the same group of respondents, I will repeat the same scale. I will repeat the same test. That way, the major thing you can notice here or observe here, the major thing is that the time gap will be there. Usually, because we know, being a human being, generally, whatever I have said, probably maybe I forget, maybe I forgot after a 1 month or 2 months or maybe 3 months. So that way, there would be enough time gap in the conduct of test and retest reliability. So firstly, suppose today I am conducting or floating a questionnaire among a group of people. So after a sufficient time period, a sufficient months of gap, I need to conduct the same skill on the same number of people. Suppose 50 people I am taking in the first conduct, same 50 people I need to take for the second conduct also, but after a particular time gap. And that way you need to collect the scores of the respondents, and those scores you can find the coefficient of correlation among or between the scores you are collecting twice, right? And if your coefficient of correlation is approximate 0.7 or more than 0.7, you can conclude that your scale is a reliable scale as per the test retest reliability. So this way you can understand the test retest reliability using this particular diagram. Talking about the next reliability method, which is the parallel forms reliability. Again, I'm not discussing the theory part. Again, I have made one more diagram. Using that diagram, we will understand the parallel form reliability. Here you can find this particular method of reliability says, here again we will be having initially the test or the questionnaire or an instrument, right? So that we can divide into the two parts. Suppose I'm having 50 questions on a particular scale. So that way I can divide them in a two parts. Maybe I can keep first 25 in the first part, next 25 in the second part. Or maybe all the odd numbers I can keep in the first part and all the even numbers I can keep in the second part. So that way, that would be your discretion, that will be your decision, how you're dividing your scale into the two parts that you can divide. Then you can administer first part on a group of people. And after a short time gap, you will again call the same group of people and you will ask them to fill or give their responses to the second part of the questionnaire, right? So that way, group of respondents here will be the same in both the conducts, but in 2 times whenever you are conducting this, in that case, you can find this in both the times, different number of items we are giving them to response. And that way, we are collecting their scores and we are calculating the coefficient of correlation. And again, if this value is 0.7 or greater than 0.7, you can say that your scale is the reliable scale according to the parallel form reliability. Right? Talking about the next, which is the split half reliability method. So again, you can see a diagram. Here, in this particular split half reliability method, this time we will not divide the test. This time you need to divide the people or the respondents. So suppose you are having 100 respondents or maybe 50 respondents, you can divide them into the two groups, group 1 and group 2. And then same test you will give to the group 1 and the same test you will give to the group 2. And at the same time, you will administer or conduct that particular test. And from both the groups, you will collect the data and you can find the correlation between that particular data. And if again the correlation value is 0.7 or more than 0.7, you can call your scale is the reliable scale as per the split half reliability. So friends, these are the 3 methods which I just discussed. As we are talking about the SPSS, so I think all these methods are almost available there in SPSS. So we do not need to go into that how you can calculate them. So the software will perform everything for us. You need to only understand that how you can interpret that particular output which you are getting to the SPSS. And I think concept I have already explained you. Now we will see the last method of the reliability, which is internal consistency reliability. It is the most important method of the reliability checking. Using this method, usually we are checking the reliability of the data. So might be possible you people have heard about the term Cronbach's alpha. So this is generally a measure which we are using to check the internal consistency of the scale. So you can understand this particular slide. For this slide, I think I was unable to make any diagram. So everything is in this particular form, in the text form. You can read it. So the first point says it refers to the degree of homogeneity of the item in the instrument or scale, right? So that means it is quite obvious whenever I'm talking about the correlation. So correlation is what? It is a degree which we are measuring between the two particular variable, because we are measuring the relationship, how closely they are related to each other, right? So when I talk about all type of reliability, I think I had coined the word coefficient of correlation, and it is generally measuring the relationship between the two variables, right? So as the value will be high, as much as the value will be high of the correlation, so that way you can find that those two variables are very close to each other. That way you can see these two variables are very similar in nature, right? So that way you can find this particular first point, that it is only telling you the degree of homogeneity of the items, that how much the homogeneity is available among the variables or the items which you are taking on a particular scale or on any particular questionnaire. Then it tells us about what extent a test is internally consistent, or to what extent there is a good amount of balance of correlation between the constructs, between the indicators of the construct. So I think for making you understand this particular second point, I have taken an example here, which is talking about the motivation. So I'm moving to the next slide for that particular diagram. So as I said, I think yesterday I have coined the term construct, and I have also told you people this thing, that construct is nothing but it is a latent variable. Latent variable means which you cannot directly measure. So here if I say motivation, means if you will talk about my motivation, that means ma'am how much motivated you are. So I think I cannot tell you the amount of motivation I am having in me, right? Maybe sometime it happens we can with the help of their gestures and postures, their activity, we can say that this particular person is highly motivated or this particular person is demotivated, something like that, right? So that way there is no proper instrument available using that we can measure the motivation. But in statistics, or if I talk about in research, we can say this thing, we can use certain number of statements, and that way we can understand the mindset of a person, that how much is the motivation he or she is showing you for those statements, right? So that way he will express the level of motivation through those particular statements. So for example, you can see motivation is the underlying construct which you need to measure, right? And for measuring it, suppose we have taken total 10 items or 10 questions on a scale, right? Now you will find the correlation among these all 10 items. And if you are finding that these items are fairly correlated to each other, that way you can say that your scale is able to measure motivation level in any particular person in a true manner, right? So that way, when I talk about reliability, you need to understand why we are talking about correlation, because we need to see how much internally, how much is the degree of the relationship between the variables or items which we are taking on a particular scale. If they are correlated, that way possibility is high that you would be able to measure the underlying construct, right? So again, if I'm talking about these 10 items or whatever number of items we are taking, it is not easier to design. Whenever we are designing our own scale, we need to be very precautious, and we always need to meet some experts of the field, because they'll guide you how to make the or formation, or means what should be the formation of the statement of the particular question which you are putting on a particular scale. Because sometimes it happens we are quoting a question, and maybe I have quoted a question in my questionnaire in some other manner, and the respondent is taking it in some other manner. So that way it will create a problem. Will be a misunderstanding between me and the respondent. So you need to be very precautious when you are writing any statement, any question on your scale. So you need to either refer the books, refer the magazines. You need to go and talk to the experts of the field. You can meet to the academicians which are working on the same field. You can talk to the researchers who are working on a same construct, something like that. So this way, you would be able to refine your scale, and that scale will good you the better results, right? So I think this is the concept of the internal consistency. Further, talking about using the internal consistency reliability, we can find up to what extent, means true score and test score. This is a little, I can say it's a technical language, but you need to only see the coefficient of correlation value among your variables. If they are fairly correlated to each other, that way you can say your variables or your scale is the reliable scale. As I said, Cronbach's alpha we can use to test the reliability of the scale. So this particular term or Cronbach alpha, we have this particular Cronbach alpha concept was given by the American psychologist Lee Cronbach in the year 1951. And after his name, he has given the name to this particular entity as Cronbach's alpha, right? Then generally we are denoting Cronbach's alpha by alpha, and we are using the person name, that the person who has developed it, that is Cronbach. So Cronbach's alpha we are generally calling it. So again, I think I am not repeating the second point. Again, I do not need to repeat the third. Talking about the fourth, by internal consistency we mean what extent indicators of the test are related to each other. So again, test means the questionnaire, indicators means the items, right? So how much they are related to each other, you need to check. Usually we can check the reliability of the scale for the items which are continuous in nature, and also for the dichotomous scale, right? So this way, this is about the Cronbach's alpha. Moving to the next slide. This slide is showing you about the formula which we can use for the Cronbach's alpha. These two formula you can see which are based on the variance method and the correlation method. As I am emphasizing on the correlation, generally we need to use the correlation method, but I think manually we will not go into this. This is the thing we do not need to do in our case, because we are having a software. Using that software, we can calculate the value of Cronbach's alpha. Further, how you can interpret Cronbach's alpha, but I think up to till this particular point, you would be in a position to understand alpha value should be approximate 0.7 or more than that, right? So I'm starting or reading this table from the bottom. If you can see here, if alpha is less than 0.5, that means you can call it as an unacceptable reliability. If it is in between 0.5 to 0.6, poor. 0.6 to 0.7 means it's a questionable reliability. 0.7 to 0.8 is acceptable. 0.8 to 0.9 is good reliability. Above 0.9 is excellent. But whenever you are getting alpha value above 0.9, there is again one alarming situation for you. And the situation is what? This situation is known as multicollinearity in the data, right? Multicollinearity meaning is your variables are very, very, very close, because when alpha is what? It is nothing but it is a correlation value, right? So when the alpha value is 0.9, 0.91, 0.95, something like that, that means the correlation value is very close to 1. And 1 means two variables are identical in nature. Two variables are same in nature, right? So that way, that type of things you need to keep in your mind while interpreting the Cronbach alpha value. So generally, if you're getting Cronbach alpha 0.9, in that case, you need to see which items are very, very, very close to each other. In that case, you can drop those items from your scale, and then again, you can conduct the Cronbach alpha on the same data. Now, how to perform Cronbach alpha? So I think these are the steps, but I think I am not reading them. We will perform them. Acceptable range of Cronbach alpha is in between 0.7 to 0.9, as I just explained you. Now talking about can we improve Cronbach alpha value or not? So answer is yes. If you want to improve your Cronbach alpha value, how you can do that? So there are three things, or there are three steps you can perform. The very first, I am reading from this yellow circle. Yellow circle item content is saying to me, removing ambiguous and the redundant items means, as I said, if Cronbach alpha value is very high or poor, in that case you need to find whether there is ambiguity available in your scale, means your statements are clearly stated or not, whether they are having the dual meanings. You are saying in some other, you are asking in some other context, people are taking in some other context. You need to check it very precautiously, right? Redundant means if the same type of questions are repeating again and again, so they may be this way also, these can mislead to the respondents. So that type of things you need to do manually in consultation with any guide or in consultation with any expert that you can do. This is the first thing you can do. Second thing you can do, you can check whether there are missing values in your data or not. Means whether you have got some of the answer questions unanswered by the respondent. So if it is there, this can also lead to the poor reliability coefficient or poor value of the convex alpha, right? So you need to check or you need to apply the frequency distribution using the SPSS. That will show you how many of the missing values available in your data. Using that, you can remove them and then again you can perform the reliability testing. Last method is the diagnose item total correlation. This is the output we are getting once we are performing the coefficient of correlation, performing the convex alpha using the SPSS. So this I'll discuss how you can get it, but how you can interpret that I'll show you in the next slide. So usually item total correlation value should not be negative. If it is coming negative, firstly, for whatever item it is coming negative, you will drop that item. This is the first thing. But if suppose your item total correlation value is positive for all the items, in that case, you will find the most minimum value, right? So suppose most minimum value is 0.01. So firstly, what you will do, you will pick that question and you will remove that question from your questionnaire or from your data, and that way again you will perform Cronbach alpha. So generally up to 0.3 and above is okay, but if your item total correlation value is below this particular threshold value, that is 0.3 or below this, generally you cannot accept. But again, I'll tell you this thing, these are the threshold value given by so many types of practicals or so many times these things were performed on the data, and that way these conclusions were drawn. But again, I'll say, means this is only my suggestion from my side. Being a researcher, this will always be a discretion of the researcher. This is, you need to decide which item you want to drop from your scale. You need to read your question before dropping it, right? If you're finding that item is very important for you, you need to hold that item in your scale. But in that case, you can see some other question which is not contributing much, and suppose this item total correlation is also less, so you can drop that item. So that way you need to make certain permutation and combinations, and that way you need to decide which item you are going to drop from your scale, and that way it will improve your Cronbach alpha value, right? So normality, I think I'm not discussing. Firstly I'll go to the SPSS, and then I'll talk about how to perform the reliability checking in the SPSS. So I think it is fine. Any doubts?
Yes, ma'am. Very good.
Doubts?
You have explained very well.
Okay, so that means I can move ahead.
Please, ma'am.
Fine. So now I think I am expecting everyone of you to open the sheet which was given by me with the name customer satisfaction towards the restaurants .scv file. If you have opened it, please give me a nod by unmuting yourself. If not, you can discuss with me some things if you want to. I'm waiting for you to open the file because it is important to perform along with me. Any questions so far?
Ma'am, can you share that file in the chat box, ma'am? Because I'm not in the WhatsApp group.
In a chat, I think, ma'am, I don't know from where. I am not getting any attachment symbol here. So how to do that? I need to check it. In a chat, there is no option coming for the attachment. Maybe the host can do that. I'm not the host of the meeting.
Okay.
I think there is. I'm not the host. Yogi sir, are you the host of the meeting? Sir, is it possible for you to share the file in the chat box, which I shared on a group? I'm not. No, sir. Actually, the participants are asking us to share the file in the chat box of this meeting. People are saying they are not there in that particular WhatsApp group. So, is it possible for you to share here? Because I'm not the admin, I cannot see that symbol of attachment here. So, I cannot attach my file. Sorry, sir. Okay, so I don't know who is asking. May I know the name?
Shravani, ma'am. Hello.
Okay, Shravani ma'am is asking us to share. Ma'am, why can't you join the WhatsApp group? Can you join that group? There we can share again.
Ma'am, I received a mail, but in that WhatsApp link is not given for me.
Okay, so Yogi sir, can you do a favor and share the WhatsApp link in the chat box?
Ma'am, which file uh, I should open for now? There are files, na customer service.
Yes, yes,
fi-
similar. That file we need to use right now, sir. In the same file we need to use customer satisfaction.
Okay, madam. Thank you.
Yeah. Okay, I think Shravani ma'am, you can find the link in the chat and you can join the WhatsApp group. And once you are joining,
Yes, ma'am. Yes, ma'am.
please let us know. Shravani ma'am, have you joined the group?
Joining, ma'am. 1 minute. Joining.
Okay. Uh, so shall I start?
Yes, ma'am.
Yeah. So I hope Shravani ma'am you have joined. I request Yogi sir, Yogira sir, will you please share the sheet?
I've joined, ma'am.
Join.
Can once
Okay,
again share the document, ma'am?
Fine, fine. Thank you. Yogira sir, can you share the sheets again?
I got the document, ma'am.
You got, yeah, I think someone has shared. Ruchi ma'am has shared. Fine.
Thank you, ma'am.
So,
Thank you so much.
yeah, thank you, ma'am. So now we are starting talking about the checking of the reliability using the SPSS. So in the variable view, you can find these total items listed were 31, right? You can find total 31 items are listed here. And using your label, you can find what is the meaning of these questions, right? So this is about the customer satisfaction towards restaurants, means how the satisfaction is being developed among or in the customers which are going for a particular restaurant. These are the certain questions which we have asked from the customers. And on a Likert scale, you can find they have given us the respondent, whether the persons are agreeing or disagreeing with these particular points. Accordingly, they have shown their agreement label to us on a scale of 1 to 5. So in the data view, you can find this is the data available with us. Now to check the reliability, the steps, now I'm telling you the steps. You need to go to the Analyze tab, right? Then you can go to the scale and then you can find the reliability analysis. So I think I have kept it on hold. If you want to take a snap of this, you can take that. Or if you want to note down the steps that you can do, analyze, scale, and reliability analysis. This is what you need to do. Fine.
Yes, ma'am.
Yeah. Once you are able to locate it, you need to click on this reliability analysis. And then you can find a dialog box is popping where you can see all your listed variables of your particular sheet are available at the left hand side. So what you need to do, I am pressing Control A from my keyboard. That you can do, or if you want one by one, you can shift. Also, you can shift your variables you in the items box. So I have shifted. I have selected all the items in a one go using the Control A key. I'm using the arrow key to shift these items from the left box to the right box like this. This is what I did. Till now it is fine. May I proceed?
Yes, ma'am.
Further, you can see or you can click on the button available with the name statistics. You need to click on this. And then in the first section, you can find descriptives for. So here you need to select the item, scale, and the scale if item deleted. So you will get the descriptive statistics for your items, also for your scale, and also for the scale if you are deleting any particular item from the scale. So this way, these three check boxes you need to check here, and then you need to press continue button. So may I press continue?
Ma'am, why we are selecting these three options?
As I said, we need to check the item total correlation.
Okay.
Yeah. So may I?
If I have selected only two, then
Sorry.
if I selected only item and scale, not selected
So
scale,
ma'am,
if item is
you can find here. It generally if, means if you will not select these three, even then you will get the item total correlation. But here you need to check means and it is not mandatory also, right? So you can read the section. The section is saying descriptive score. Descriptive means the descriptive statistic means mean and standard deviation. If I say. So you need to, if you want to see what is the mean value and what is the standard deviation value for the each item of a scale, that way you can check this. Similarly, for all means combining of all the items for the particular scale, what is the mean and what is the standard deviation, that way. And if you are deleting any item, whether there is an improvement in the mean value and standard deviation value or not, so that way we are checking or we are using these three for that purpose. So generally, mean and standard deviation also plays very important role when I talk about the reliability of this. So that is why we have checked these.
okay, ma'am.
Fine. Now you can press on continue button, and here in the model you can find the model is saying it's alpha, right? That is Cronbach's alpha. You can click on the drop down, and you can find these are the remaining types of reliability methods available. According to your need, you can use that. But if you want to perform factor analysis or something like that, generally you need to check the Cronbach's alpha value, and it is well known and well used or very famous method generally we are using for checking the reliability of the scale. So that is why we will go with the by default option, and then you need to click on the OK button. Once you will click on OK, you would be able to see in the output window you are getting the results where you can interpret your results. The first section is talking about case processing summary, which says we are having total 121 cases and there is no missing value available. That means nothing is excluded from your data. So you are getting total 121 valid cases, right? Going to talk about the second table, which is talking about your Cronbach's alpha value. So this value is coming as 0.672, and you can recall when I was talking about the conceptual aspect of the reliability, I said it should be between 0.7 to 0.9. Generally, it is this threshold figure. But here you can find this value is near to 7, but it is not 7. So now I think I had a word with you regarding how to improve that. So now we will see that thing, right? We will see whether we can improve it or not. Now further I'm talking about the second section or next table, which is the descriptive statistics table. Here you are getting the mean standard deviation value for each and every item. So if I talk about the modern equipment, you can find the mean is coming as 1.49, and 1.49 is what? It is below 2. And if you are knowing, if we are talking about Likert scale, as I said, we have used the Likert scale, 5-point Likert scale. And 5 options we have given: strongly agree, neutral, disagree, and strongly disagree. And when you are coding your data, we are giving generally 5 to strongly agree and 1 to strongly disagree. That means it is above 1 but below 2. That means it is in between strongly agree and disagree. strongly disagree and disagree, right? That means people are saying they are strongly disagree with this thing that modern equipment are leading their satisfaction. Maybe this can be the one thing, right? So that way you can interpret these mean values for yourself, right? Similarly, standardization, if I talk about, this should not means here as ma'am, I don't know who I was asking me at that time. So generally you need to check whether your standard deviation is below your mean value or not. It is a rule. You need to check your standard deviation should always be less than to the mean value. So here you can find which is very in each and every item's case we are finding it is less than to the mean value, right? Further, talking about the important table, which will help you out to improve your Cronbach alpha value. So here I can talk about the first column, which is telling you scale mean if item deleted. Means if I will delete my first item, first question, which is based on modern equipment from my scale. So in that case, the total mean value for the scale will be 96.74. Similarly, if I'm deleting this item, variance will be 147.242. Right? And then you can find item total correlation will be 0.030 and Cronbach alpha if item deleted. So what will be your Cronbach alpha if you are deleting your question number 1, which is 0.675. So this way you can find at the last column whether anywhere you are getting 0.7 or above that. So I think you can see nowhere we are getting 0.7 or above this, right? So that means if I delete any of the item using the or any of the item from the scale, so that is not improving my Cronbach alpha if I'm looking at the last column, right? So you need to refer the second last column, which is talking about the item total correlation. So firstly, if you can recall, I said you need to check whether for any item you are getting this value as negative value. You need to go down and check. I think, yeah. I think for the two items, I can see the value is negative, right? Which is minus 102, sorry, minus 0.102 and minus 0.110, right? So these two are the negative figures. Fine. Is it okay? Everyone is able to look at them, right?
Yes.
Yes, ma'am.
Yes, ma'am.
Now, the most negative I can say it's minus 1.02. Sorry, minus 1.110, which is for the attentive attitude, right? So that means firstly, I can remove this particular item from my scale and I need to check whether is there any improvement in my Cronbach alpha or not. So now what you need to do, again, you need to go to the analyze, then scale, and then reliability analysis, right? So I'm clicking on this. Now you can see here you need to find your question which is related to the attentive attitude. Question number 23. So I'm shifting this into the left box again. So I'm sending it back in the left box using the same arrow button. Is it okay? Everyone has done that?
Yes.
Yes, sir. Yes,
Now-
ma'am.
Yes,
Sorry.
ma'am.
I'm not getting asking something. Do I need to repeat it again? Anyone is saying something?
No, ma'am.
Okay, fine. So you can click on the OK button now to get the output. Now you can see once I have pressed on the OK button, I can see the Cronbach alpha value has improved. I think little bit it has improved. Previously it was 0.672, I think. Yeah. Previously it is 0.672, but now it is 0.689. So now what we will do? Now we will pick the second negative item total correlation value, which was for the personalized services, right? I think this is the single negative value we are having on our scale. Yes. Right? Fine.
Yes, ma'am.
So click on analyze, go to the scale, click on the reliability analysis and find personalized service. Question number 24. Again, send it back using the arrow key. You do not need to make any other changes. So may I click on OK?
Yes, ma'am.
Yes,
Yeah.
ma'am.
So now you can see once I clicked on OK, I think we can see it's a good news for us. Now Cronbach alpha value has improved. It is 0.701, right? So that means we have removed 2 items from 31 to we came on 29 items, and that way the Cronbach alpha value has improved, right? So you need to check this. Means this way we can do the things, or we can send some other figures or some other items also back in the left box, and we can see whether the changes or the good improvement is coming in your Cronbach alpha value or not. But again, I'll tell you one more thing. Number of items we have taken initially were 31, but now I have shifted 2 items, or I have removed 2 items, so it came to the 29. So this will again be a decision of the researcher, how many items will for you, up to how much items you want to, or up to or how many items you want to keep on your scale. That will be your decision, which item is more important for you, that you need to decide, right? So this way you need to do this type of trial and error methods you need to use, and that way you can get, or you can see the improvement on your Cronbach alpha value. Now you can find almost every value is positive, but still some of the item total correlations are very small. So that would be totally the call of the researcher. If you want to improve them, you can send some more item to the, or you can drop them from the scale, and that way you can see the changes, right? So I think this was about the reliability analysis using SPSS. Now we will proceed further and talk about the normality. So is it fine? May I proceed with the normality?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yeah. Thank you. So I think I shared my slides. Visible?
Yes, ma'am.
Yes, ma'am.
Fine. Now you can see I'm talking about the normality. As initially Indranil sir has said, when we talk about normality, we are interested to see whether the data is skewed or not, right? Skewed means I think we all are from the academic side, and if not, maybe we have studied this thing in our academic time. We know this thing whenever we are talking about normality, we are talking about the bell-shaped curve, right? We need to see the distribution of the data, whether our data equally distributed to the mean value or not. You need to check that, right? So the bell-shaped curve, maybe I have taken, yeah, you can see this is the second middle curve is the bell-shaped curve. This is the better or the exact bell-shaped curve. Here, if I'm talking about, I need to see generally your median will lies. Generally your median lies. Mean lies at the middle of your bell-shaped curve, right? So this is nothing but this is your mean value, and we want to see 50% data should lie at the left hand side, 50% data should lie at the right hand side. This is what we need to see. If this type of distribution of data is coming from mean, 50% data is coming left, from mean 50% data is coming to right, in that case you can call it as a normally distributed data, right? So there are certain parameters to ascertain that thing. If you have studied statistics, you are knowing this thing. There are certain characteristics of the normal distribution. So these some of them I'm telling you. That is, generally mean, median, and mode should be same, or I can say mean should be 0 and standard deviation should be 1. This is generally the rule of the normal distribution curve. But it is I'm talking about the perfect normal distribution curve. This is the standard normal distribution curve I'm talking about. In the real world, I think it is very hard to get such type of data, right? So you need to say this thing that mean, median, and mode should be the similar for the normally distributed data. Then you need to find that the skewness value should be, usually for standard curve it should be 0. For and the kurtosis value should be 3. Skewness means symmetry. You can find the left and the right side of the graphs on the slide. You can see. So these are showing you the skewness of your data, right? So if your right tail is greater than your left tail, this is positively skewed data. When your left tail is greater than your right tail, this is the negatively skewed data, right? So that way you can find, means when your mean is less than to median, median is less than to mode, means when the mode value is the highest value, this is the negatively skewed data. But when your mean value is the highest value, that is the positively skewed data, right? And you can see, I think I have written here also.
Ma'am, I want to know actually, which one is good, ma'am? When we
Sorry?
are available, ma'am, negatively skewed data is good, or I mean, which one is better, ma'am? On all of them.
I'm not getting you.
Ma'am, I'm telling that among all of this card, which one is good, ma'am? Like,
I think it is very obvious. If I talk about normally distributed data, so the middle one is the good one. But
okay,
as I said, in the real world, sir, I think it is very hard to get this type of graph for the data, right?
yes, ma'am.
Because data is maybe biased, or whenever we are collecting, so some biasness is coming from our side or from the respondent side. So data will not never be this perfectly distributed data we are not getting usually. So might be your data will be according to the this left graph or according to this right graph. Maybe something I can say little symmetry can be there, but not the exact symmetrical data you can find usually in the life. But the middle one is the perfect normal distributed data, right? You can find here I have written normal, no skew. That means no
Thank you,
skewness
ma'am.
is available. This is negatively skewed and this is positively skewed. So generally we are looking for this because there are assumptions of statistical tests which are talking about the normal distribution of the data. But being a researcher, we need to do some adjustment with these things, and there are some threshold values available, and that way we can find. So as I'm talking about skewness will tell you the symmetry of your data. If your data is symmetrical to your mean, means your skewness value will be 0. 50% data is here, 50% data is here, right?
Uh, ma'am, actually, sometimes some researcher used to manipulate their data, no, ma'am. So how it will be understood? Like,
Sir, that will be a ethical consideration they should not do. This is what I can say. They should not do this, but I think if you are statistically sound, any person who is statistically sound can do such type of thing.
yes, thank you, ma'am.
Yeah. So ethically, they should not do that. And if they are submitting their paper in any journal, and if reviewers are able to find that thing, maybe they will be punished, right? Now, talking about further, kurtosis will tell you the sharpness of your curve, whether your curve is very sharp. So your data is leptokurtic or platykurtic or mesokurtic. These are the three things we are talking about in terms of the kurtosis. So the standard value of the kurtosis is 3, right? And the skewness value should be 0. This is I'm talking about in terms of standard normal distribution. And again, I'm repeating, usually in the present world or in the real world, it is hard to get these figures. So that way, there are certain threshold values which we will see once I'll talk about the normality using SPSS, right? Now, what are the methods which we can use to check the normality of the data? Usually, there are 2 ways of checking the normality. First is the numerical methods. Second is the graphical methods. If I talk about numerical methods, we can keep skewness and kurtosis as an indicator of normality. We can use Kolmogorov-Smirnov test and also the Shapiro-Wilks test. Apart from that, if I talk about graphical methods, you can use histogram, QQ plot, and box plot to check the normality of the data. So we will see all in the SPSS, right? So I think I'm not going much into detail. We will see all these practically using the second file which I have given to everyone. So the file name is, I think, employee dataset, right? I hope you people have received the file, right?
Yes, ma'am.
Yeah. So I'm expecting you to open it. Do I need to wait or can I start? Any confirmations?
Yes, ma'am. Please start.
Okay, fine. Now you can see here I am having a data set in which there are so many variables available. And in our upcoming days, we need to use the same file. When I talk about the T and the ANOVA, in that case also we are using the same file. So you people need to please reserve this file with you. In upcoming days, we will using the same file, right? Today, in context to the normality, if I'm talking about, I'll talk about the salary variable here. Usually, whenever I'm talking about the normality of the data, we need to have a continuous variable. We need to have a numerical variable. For that, you need to check the normality. For the categorical and ordinal variable, you do not need to check the normality, right? So this is the first, maybe I don't know if I can say this term or not, misconception of what, but you need to be aware about this thing. If you are checking the normality of any particular data, you need to know your data should be on a continuous scale. Interval or ratio scale data you need to have, right? So I'll talk about the salary, normality of the salary. So you need to go to the analyze menu to check the normality. So I'm repeating, go to the analyze, select descriptive statistics, and go to the explore. So these are the steps to reach to the exact place where from where we can check the normality. I'm repeating: analyze, descriptive statistics, and explore. May I click on this?
Yes, ma'am.
Yeah. So once I'm clicking on this, you would be able to see we are having all the variables listed. I'm selecting the salary, that is the current salary. I'm shifting this into the dependent list box. So I think you need to shift your continuous variable and shift it to the dependent list box to test the normality of your data. After shifting it, you can click on the statistics button. Once you're clicking on the statistics button, you would be able to see descriptives is by default selected by SPSS. So that we need to get. I think we are requiring this thing. It is by default selected. So we will press on continue button. That means nothing you need to choose from the statistics button. Whatever is the by default, we will go with that. Second, you need to click on the plots button. In the plots button, in the first section, we can find box plot is there. And as we are dealing with the single variable, so we will go with this first option. And even when you are dealing with your, here you can find, if you're shifting the factor variable also, factor variable meaning is independent variable. In that case also, we can go with the by default option, right? In the second option, in the second section, which is talking about the descriptive, stem and leaf is selected. This is a very old method, so I'm deselecting this and I'm selecting the histogram here, right? Now talking about the normality plots with tests. So if you want to generate the QQ plot, as I have discussed, these are the graphical methods we can use to test the normality, right? Box plot we have taken, histogram we have taken, QQ plot you will get from here. And apart from that, the two methods which I'm talking about, the Kolmogorov-Smirnov and Sapir-Whorf, both you are getting here. You need to click or check this particular box. This is all you need to do here. You can press on the continue button and then you can press on OK to get your output. In a few seconds, I hope you will get the output. In my case, it is taking time. It is showing running exam. Anyone who got the output?
Yes, ma'am.
Fine. Yeah, we got it. Now you can see the first table, which is case processing summary table. This table says for the current salary, we are having total 474 observations and there is no missing value. So total is 474, right? So this is a very simple table we are getting here. Talking about the next table, which is about the descriptives. So here you can find for the current salary, the mean current salary or the average current salary is $34,419.57. Second section says 95% confidence interval for mean. Lower bound is this, upper bound is this. In a simple manner, if I want to make you understand this term, I can say if we are picking the same, from the same population, if we are picking some other sample, so chances of falling the mean value will be in between this particular range. So, for example, this is the data of 474 employees of any particular organization. So, from the same population, maybe same industry or something, if I'm taking some other employees, right, and if I'm collecting their current salary value, and I'm calculating the mean, so the chances of mean salary will be that means that mean salary will fall in this particular range. So this is the meaning of 95% confidence interval. That means 95% chances are there that the mean salary of that particular sample will fall in this particular range. Then 5% trimmed mean. Trimmed means you are trimming something, you are deleting or removing something. So your trimming is 5% figures you are deleting from the left side, 5% you are deleting from the right side. So that way you need to check, because sometimes it happens you are having the outliers in your data. Outliers are the extreme values which are not very much similar to your data points, right? So that way you need to see if if mean value, if sorry, outliers are present in your data, so they will impact your mean value. So if you are removing 5%, you're removing from both the sides. So this would be the mean figure. And now if you can see your actual mean and your trimmed mean, you can find there is a difference, right? Approximate $2,000 difference you can find there. So that means it shows that there are some influential values or some outliers available which are impacting your mean value, right? Talking about the median, this is the median current salary, this is the variance of the salary, standard deviation, minimum current salary, maximum current salary, range. I think we all know maximum minus minimum gives us the range of the salary. Interquartile range is the difference of third quartile and the first quartile. Skewness is 2.125 and kurtosis is 5.378. If you can recall, I said using the skewness and kurtosis also we can ascertain or comment on the normality of the data. As I said, generally skewness value should be 0, but here we are getting the figure as 2.125 and kurtosis value is coming as 5.378, right? So you can note down there are threshold values for these two. For skewness, we can take the threshold range as -2 to +2, and for kurtosis, we can take that range as -3 to +3. So if your kurtosis and skewness values are falling in this range, in that case, you can comment that your variable is approximately normally distributed, not exactly, approximately normally distributed, right? So here you can see, if I talk about skewness, I said the range should be -2 to +2. So here it is exceeding that range. Kurtosis -2 to +3, it is again exceeding the range. That means I can comment that the salary is not normally distributed here, right? Now, one more method, if I talk about test of normality, Kolmogorov-Smirnov and the Shapiro-Wilks. So if generally when smaller sample size we are having, we need to report the Shapiro-Wilks, and if you are having the enough or the large sample size, in that case you can go for the Kolmogorov-Smirnov test, right? So here we are having 474 observations only. I'll report for the Shapiro-Wilks test. So if any one of you are making the notes, right, please write down the hypothesis for the Shapiro-Wilks test or the Kolmogorov. For both the tests, the hypothesis will remain same. Hypothesis is variable is normally distributed. Variable, you can replace whatever variable you are talking about, right? So it is current salary. So current salary is normally distributed. This is my null hypothesis, right? Now I think you people are aware about the significant value, which is your p-value. So the thumb rule says if your p-value is less than 0.05, in that case you need to reject your null hypothesis. So you can see this particular value is less than 0.05. That means we are not holding our null hypothesis. So we are again commenting that variable is not normally distributed. So now we have ascertained normality using these two methods, right? Moving ahead, talking about a histogram. You can find in the histogram, again, if I see the shape of my histogram, it is showing me, it is which kind of histogram? It is positively skewed histogram. That means there are very less number of people who are getting higher salary, right? Here at the right hand side, salary is increasing, but these bars are very smaller in the magnitude in a shape, right? So that way we can say there are very less number of people who are drawing the larger amount from the organization, right? Now, if you want to put a bell-shaped curve on this, you need to double click. So once you will double click, you would be on a chart editor, right? Here in the chart editor, at the bottom, you can find there are various types of icons available. The second last is for the distribution curve. You need to click on this. Once you will click on this, the properties dialog box will open. And here you can find that normal is by default selected. You need to only close this, right? And once you are closing out chart editor, you would be able to see the normal distribution, that is the bell-shaped curve on the histogram. So it is clearly showing that your right tail is greater than your left tail. That means your data is positively skewed data, or your salary variable is positively skewed. Is it okay?
Yes, ma'am.
Yes, ma'am.
Any question?
Yes, ma'am, I have a question.
Yes.
Ma'am, what number of observations should be there to make a choice whether we should take Kolmogorov or Shapiroval test?
Generally, below 1,000, we will go for Shapiro, and above, you need to check the literatures once, ma'am. And literature things are given. Once I have read somewhere, it is approximate when you are having the sample size up to 1,000, you can go for the Shapiro. Above that, you can go for the Kolmogorov.
Okay, ma'am. Okay.
Going down, talking about the QQ plot, that is quantile plot. So you can find if these data points are following your fitted line, the black solid line. If they are exactly following the line, that way we can say that the variable is normally distributed. But once they are coming like this, so this is the positively skewed data. If this is reverse, means this curve is coming down, in that case, this will be the negatively skewed data, right? Then detrended normal QQ plot, we do not need to report anyway, anytime. You need to only talk about now the box plot. Box plot is generally the combination of 5 things. The middle line is the median. This is the median salary. So you can see once you will extend this line till this particular axis, you will be able to get this. This would be your median salary, right? Then this upper wall or the upper layer of your box is known as the third quartile. The lower one is known as the first quartile. Then this part is known as the upper whisker and this part known as the lower whisker. And beyond these whiskers, if any data points are falling, they will be treated as the outliers, right? These outliers can present at both the tails, left and right both. It is quite possible. But here in this case, you can find we are having all the outliers at the right hand side, and the same thing we have seen in the histogram also. In the histogram, we have seen that the right tail was very high, right? So that way, these are the outliers available in the data. So initially, you can find there are so many circles pile up on each other, and as we are increasing from this to the this one, these are converted into different shapes. These are the asterisk signs, right? So meaning is that these are the significant outliers. That means they are compulsorily or they are definitely impact your results, right? So generally you need to focus on the asterisks. So if you, this would be your call whether you want to drop these points, data points from your data or not. If you wish to drop them, you can drop them. So for that, I'm double clicking on this, right? Once I'll double click on this, you would be on a chart editor. Here you can come on any particular circle, right? So suppose I selected this, right? I have just click on this asterisk first, the uppermost asterisk, and that way you can see some circle is coming around this, right? I am doing a right click on this. Once I am doing a right click on this, you can see it is showing me go to case in the box. I'm clicking on this. Once I'll do that, you would be able to see I am landed on my data sheet where it is highlighting me the case number 29, right? So this is the case where you can find the highest salary is coming as 1,35,000. So this is the extreme salary in the data, and this is the extreme outlier available. Means there is possibility that there is only single person or 2 person who are drawing this extreme value salary, right? So that would be your call whether you want to drop this data from your particular data set or not. And that way, according to your discretion, you can drop them, and then again you can perform this normality checking, and you can see its impact on your results, right? So this way we can make changes or improvement in the reliability of the, normality of the data, right? So I'm closing this. Yeah. So this was the last output which we have got using the explore option of the SPSS, and that way we can ascertain normality of the data, right? I think this is all from my side for that day. Now I think platform is open for the question and answer.
Excuse me,
So
ma'am.
Yes.
Ma'am, please once go to normal QQ plot. Ma'am, exactly, like I cannot get what is that.
Normal QQ plot I need to explain again.
Yes, ma'am, please.
Okay. So I think this is the normal QQ plot, right? I said this is the fitted line, right? If your data points, these are your data points, if they are exactly following parallelly to or they are overlapping your this fitted line, that means your data is exactly normally distributed, right? But some deviation is coming, in that case there is a problem with the normality. In that case, you can find it is bending, right? It is making some curve. This curve is upper side. So this is the positively skewed data. If this curve will reverse, this will be the negatively skewed data.
Okay, ma'am.
Okay.
Ma'am, I have one question.
Yes,
Ma'am, how to remove outliers and how many outliers I can remove from my side?
I think, sir, I have given answer already. This would be totally the discretion of the researcher. There is no, what I can say, rule is given in statistics where you can decide upon. You need to see up to how much, what risk you can take with your results. That will be your call, right? As you can see, when I was discussing descriptive statistics, we have seen there was a 5% trimmed mean, right? Means it is removing 5% data from left, 5% data from the right. That means we are talking about only the 90% data from the left and right, both sides we are removing the data, and we are talking about only the 90% data. So if you are going with this, you can mention this in your research, because for each and every step we are taking in the research, answerable will be only we, right? So that would be your call. Generally, as you can see, there was one extreme point available, 1,35,000. That was a very extreme case. So that way, 2-3 points generally we can remove. But every time, which whatever we are removing, again we have to perform, because might be possible in from the one, what I can say, dropping of a particular item, maybe it has improved a lot. So that way, you need, this is the type of thing you need to do again and again, and maybe you can get some good results. So I think I cannot comment up to how much extent you need to remove. I am not a good person for commenting on that, because even I haven't studied this thing in any of the books.
Thank you, ma'am. Thank you for your reply.
Thank you
Okay,
so much.
ma'am. That means we can move ahead even when the data is not normally distributed.
Not getting, ma'am. Mona,
Means like whatever analysis we got through normality distribution and without making any correction, can we move ahead with data analysis part?
ma'am, usually if I talk about the journals which are accepting the research papers or something, so that would be means again the discussion. Suppose I decided I want to submit my paper on in so and so journal, right? So firstly, I need to go and see clearly what are the norms of the journal. Also, I need to see what type of papers were published there. I need to look those papers and I need to see what type of things they have done in the paper, and accordingly I need to decide upon whether because once you will read this data analysis part of any particular research paper, you would be able to understand whether the so and so authors have performed these type of checkings of the assumptions of the data or not, or of the test or not. So that way you can understand if that type of journals are not demanding those things. In that case, you can, without checking also, you can go ahead.
Okay, ma'am.
Because here one more thing I want to comment for the normality, especially in statistics, there is a theorem available with the name central limit theorem, right? So this theorem says when we are increasing the sample size from 30, as we know in statistics generally there is a rule, if sample size is below 30, we need to perform t-test, and usually people are asking this thing. But there is one more rule. If you are increasing your sample size from 30, even t distribution becomes your normal distribution, right? So gradually increment of the sample size can lead to the normal distribution of the data, but in some cases might be possible even with the good sample size, your data is not showing the normal distribution. So in that case, again I repeat, this will be the call of the researcher.
Okay, ma'am.
Fine. Any other questions? No questions?
No, ma'am, I have a question. Ma'am, can you please give the example of reliability analysis and Cronbach alpha in case of parallel tests, where we
Not
have
getting, ma'am.
reliability analysis and
Mhm.
Cronbach alpha for parallel tests, in which we have administered that test on the same participants in a short frame of time.
Yes.
Ma'am, for that, how can I do it in SPSS?
Ma'am, usually whatever data we are feeding, SPSS is not knowing which type of data we are feeding in this particular software, right? So that would be at the time of your collection of the data. You need to see this thing, that what is the concept of the parallel or the test retest reliability, right? So using that, you can collect the data, and once you are feeding that data, that particular SPSS will help you out to get the results. So this would be at the time of your data collection. You need to decide. You need to be precautious at that time.
Okay, ma'am. I've collected data for parallel test in which we have which I have administered a test 6
So anyone
times.
has suggested you to perform parallel test reliability?
Sorry, ma'am.
Someone has suggested you to perform parallel test
Yes,
reliability?
yes, ma'am.
Sorry.
Yes.
Yes.
Yes, ma'am. I have checked. Basically, my research is on equivalence of psychometric parameter, equivalence of a test in which we have 6 parallel forms, and I have collected the data on the 6 parallel forms. For that, how can I do that in SPSS analysis part?
Ma'am, you need to feed your data and then you can select that parallel form reliability. As I said, SPSS is not knowing whether you have used the parallel form concept for collecting the data, because it is only asking you to select your data and transfer it, and you need to select the method that is parallel.
Okay, ma'am. Okay.
Yeah. Anything else? Yes. Any questions?
Ma'am, good evening. Ma'am, I am from sports field, so our data is basically based on quantitative data like a long jump, 5 meter, high jump, like this. We used to calculate our data in meter or second. So, madam, while analyzing, how I will get this interclass correlation coefficient? of-
Sir, just a minute. I think you're not clearly audible. I need to switch off my cooler for a minute. Yeah. Please repeat. Sorry.
Okay, ma'am. Ma'am, I was asking that in the sports field, we are using much of the time that quantitative data, ma'am,
Hmm.
like long jump, 5 meter, high jump, and all this, or in either in meter or second. So,
Hmm.
madam, how I will calculate my test? Like how I will find interclass correlation coefficient of this interclass correlation coefficient of
Which correlation coefficient?
interclass, ma'am. Intra-class.
Intra-class.
Yes, ma'am.
Sir, usually
Coefficient
for
of my test, like
sorry.
retest reliability, ma'am, or coefficient of my test. How reliability? How will find?
Sir, usually I think you need to understand the concept of reliability and normality. As I said, reliability we are testing or using for a scale,
Hmm.
right? And if I talk about this particular thing, that is the normality we are talking about a variable. So if you are collecting your data using a scale, because here you are talking about the variables, you need to check the normality of it.
Like,
In
ma'am,
that
I am
case, there is
telling,
no role of reliability.
ma'am, I was telling, suppose I have taken 60 meter speed sprint run, and so after then my test, how I will find this R value and like interclass correlation R value, how I will
The
find this, ma'am?
coefficient of correlation you can find using the two variables. Compulsorily,
Yes,
you need
ma'am.
to have two variables. If you are having two variables, you can find them. You can shift your data easily. When I think at the last day we will see this correlation performance using the
Yes, ma'am.
SPSS. You need to shift your variables. Whatever two variables you are having, you can shift them in the box, and you can use select the particular method, and you can click on OK, and that way the results will be generated for us.
Yes, thank you, ma'am. Thank you.
Okay, sir. Or I think you can do one thing at the last day. We can see if you are having the data, you can perform that.
Okay,
Right?
ma'am. Okay. Fine, fine. Thank you.
Any other questions? Any no questions? So, can we go for a pic? Is it possible for you to switch on your cameras? Indranil sir. Yeah, Neha ma'am. Anyone else who is switching on his or her camera? Or okay, I can find 2 beautiful faces today. Just a minute. I'm capturing. I think one more. Sir, give me a minute. I need to capture you one more time. Give me a minute. Yes, I captured. Thank you, everyone.
Thank you so much, ma'am.
Thank you, ma'am.
Thank you
Thank
so
you.
much, ma'am.
Thank you so much, everyone. I think now 3 people more has switched on their cameras. Very good.
Sita, cycle travel it.
So I think it's all for from my side for the day. Anyone?
No, second.
RFI is available. Yogra sir, are you available?
Yes, Chanchala ma'am.
Okay, Ajay sir is there. Ajay sir, we are done with the session today.
Yeah. Thank you so much, ma'am. Thank you so much.
Thank you so much,
Thank you all
Ajay sir.
participants.
Thank you, everyone. Good night, Ajay sir. Good night, everyone. We will meet tomorrow for the next session.
Yeah. Thank you, ma'am. Thank you. Thank you so
sir.
much.
So, Ajay sir, may I leave the meeting?
Yes, ma'am. Thanks a lot, ma'am. Thank you so much.
Yeah, thank you so much, sir.